in 36, we're solving for the value of x. Now here we have vertical angles. Since they would form our bow tie, right, they're congruent to one another. So we can write x plus 16 equals 5x. And when we subtract x, we get 16 equals 4x. And then we can divide by 4, so we get 4 equals x. In 37, the angle right here tells us that these two angles are going to be complementary. So we're going to take 4x plus 3, and we're going to add it to x minus 8, and that's going to equal 90. So 4x plus x is 5x. 3 minus 8 is negative 5. That equals 90. When we add 5 to both sides, we get 5x equals 95. And then we can divide by 5. So we get x equals 19. In 38, these two angles form a linear pair, which means that 7x plus 10 plus the other 3x is going to equal 180. These guys are supplementary. So 7x plus 3x is 10x. So we get 10x plus 10 equals 180. When you subtract 10, you get 10x equals 170. And when you divide by 10, x equals 17. (39) is a proof. And you have one proof on your final. This looks familiar. So the easiest thing that we can do is first write our givens. Due to lack of space, I'll just put a line through it. Your given is already written on your final exam, so you can't earn those points. We're told that B is the midpoint of AC, and then we're told that angle A is congruent to angle C. So if we look for a key word, well, we have midpoint, which means that it's going to split AC into two congruent parts. So AB is congruent to BC, and that's exactly what we write in statement 2. So AB is congruent to BC, and our reason is simply definition of midpoint. And then there's no other keywords, but we do have a vertical angle set here. Here's our bow tie. So we can say that angle ABD, right? Angle ABD is congruent to angle CBE, and that is due to vertical angles, right? So that's our reason there. Now, we have enough information to prove our triangle's congruent. So we can say triangle ABD, and all we have to do is match up our congruent pieces here. So triangle ABD is congruent to triangle CBE, and that's two angles and a side, and the side is in between the two congruent angles, so that is by ASA. And then we can go ahead and write our final bit here, that DA is congruent to CE, and that is because corresponding parts of congruent triangles are congruent, also better known as CPCTC. Now in the next section, we just want to find the value of the variable in each of our pictures. So we have a variety here. In the first one, this is one of those where I would say, hey, write the table. The one where we had small, medium, and large this way. We had short, long, and hypotenuse this way. Okay. The unfortunate part is I don't have a lot of space here. I can try to cram this in here. So short triangle, or small triangle, short side is 4. Long side is X. Hypotenuse is Y. And then our medium triangle, short side is X. Long side is 25. Hypotenuse is Z. And then our large triangle, short side is Y. Long side is Z. Hypotenuse is 25 plus 4, 29. And then we can go ahead and we can write our proportions. So the first one that we have is in the upper left corner there. It's 4 over X equals X over 25. So when you do this problem, you get X squared equals 100. And the square root of 100 is just 10. And then if we take a look in the four corners, we have 4 over Y equals Y over 29. So we get Y squared equals, I'm going to cheat here a little bit. I'm going to write 4 times 29 because I know I'm going to have to simplify a square root in a second. 29 is prime. 4 is a perfect square. So when we take the square root, Y equals 2 square root 29. And then the last one is Z. And that's in the lower right-hand corner there. We have 25 over Z equals Z over 29. And similar to how we did Y, and cross multiply and kind of take a shortcut here, Z squared equals 25 times 29. So 25 is a perfect square, 29 is not. So when we take the square root, we get 5 square root 29. Now 41, X is an angle, which means you can do trig. We can do sine, which is opposite over hypotenuse, so you do 3 over 5. We can do cosine, which is 4 over 5, or we can do tangent, which is 3 over 4. And so I'm going to actually do sine. So sine of X is going to be my opposite side, which is 3, and my hypotenuse, which is 5. And then the way that we solve for an angle here is we're just going to take the inverse. So x equals sine inverse 3/5. And at that point, that's what you plug in to your calculator. So on your calculator, you just have to hit second and whatever trig function you chose, and then put in your 3 divided by 5, or your 3 divided by 4, or your 4 divided by 5, depending on the trig function. So we get x equals 36.87. For 42, it looks like 40, where we might have to draw some tables and things like that. Or they're right triangles, and we have 2 out of the 3 sides, so we could go ahead and just do Pythagorean theorem a couple times over. All right, so what we could do here is, I'm going to label this guy y. So we have 6 squared plus y squared equals 10 squared. So we get 36 plus y squared equals 100. And then when we take 100 and we subtract 36, we get y squared equals 64. And when we take the square root of 64, y equals 8. So that is going to go up here in place of y. And now I can ignore the left side of the triangle and move on to the right side. And here, we can take 8 squared plus 15 squared equals x squared. So we get 64 plus 225 equals x squared. And then 64 plus 225 is 289. So 289 equals x squared, and when you take the square root of that, you get 17 for x. In 43, we're able to actually take a line here and draw that. All right, so this piece is now x up here as well. And now this side is 6. Since the whole thing is 10, that means this little piece up here is 4. And we can go ahead and just do Pythagorean theorem for that one. And we get x squared plus 4 squared equals 12 squared. So x squared plus 16, there we go, equals 144. And then we can subtract 16 from 144, so we get x squared equals 128. Now 128 is just 64 times 2, and 64 is a perfect square. The square root of 64 is just 8, so we get 8 square root of 2. (44) is a lot like problem 40. All right, so I'm going to try to write my table again. Short, long, hypotenuse. Okay, Now, short side of our small triangle is 2. Long side is z. And hypotenuse is 6. Short side of the medium triangle is z. Long side is going to be x minus 2. And then the hypotenuse is y. And then our short side for our large triangle is 6. Our long side is y. And our hypotenuse is x. So now we need to find x first, and we can use the 4 corners. So we have 2 over 6 equals 6 over x. Right. So we get 2x equals 36. Divide by 2, and x equals 18. So we can actually use that information now and erase some of our x's and replace them. So this one was x, so now it's 18. This one was x minus 2, so 18 minus 2 is 16. So now we can solve for y and z. So y is 16 over y equals y over 18. All right, now both of these have parts of perfect squares and or are perfect squares themselves. So we'll go ahead and we'll actually do the multiplying for this one. So when we cross multiply, we're going to get y squared equals 288. Now 288 is just 144 times 2, and 144 happens to be a perfect square. It is 12 times 12, so we get 12 square root of 2. For z, where can I fit z? I'll squeeze z down under the 45. That's fine. Z, we're going to use the upper left corner, so we have 2 over z equals z over 16. So we get z squared equals, well, we'll just say 2 times 16 because 2 is not a perfect square, nor is it made up of perfect squares. So we know 16 is our perfect square, so z equals 4 square root of 2. And then number 45 on here is an isosceles triangle. So when we have an altitude drop down, this one right here, it actually splits the opposite side into congruent pieces. So this side is 4 and this side is 4, which means we can take x squared plus 4 squared, and it equals 5 squared. So 4 squared is 16. 5 squared is 25. 25 minus 16 is 9. And when you take the square root of 9, you get x equals 3.